Hi guys, today you're going to be learning how to find the surface area of a cone. This is like the second half of 8-8, and the first half was to find the surface area of a pyramid, and today we're going to take that just a step further, and instead of having a base that's a square, you're going to be having a base that is a circle. So, a couple of things to review. A right cone is going to be what we're working with this time, and it's going to be a line perpendicular to the base. So let's see, like it kind of comes down the center, and this is going to create a right angle here, and I'm kind of surprised that this doesn't have that in there, and that's hard to see. But a right cone is just going to have that right angle that's perpendicular to the base, and it's going to go straight through the center tip of the cone. The slant height is something that we just started working with this week with pyramids, and the slant height for cones also is going to be down the side of the cone, not up the center of it through the vertex, but the side of the cone. And that is going to be represented with this symbol that looks like a cursive L. So slant height we've been using now a little bit, and I'm just going to write it all over the place, but this is slant height. Slant height is not E, it's actually cursive or italicized L. So the formula that's important, and I really don't like how they make these so tiny, but it's this one that we're going to be using. So surface area of a cone is equal to pi radius squared, which is going to be taking care of that base, and then to find this area, which we also call our lateral area. Whoops, I was trying to move my picture. We're going to add to that pi times radius, which is going to be this, times the slant height. Again, that's not E, but that's slant height. So we need radius, and we need slant height for every question that we're going to be answering. So let's do some examples. So we're going to find the surface area of the cone, and we want to do that to the nearest tenth. It's been very consistent throughout this unit. And then we're going to use the pi button on our calculator. So our formula that's brand new to us, this is the first time that you're going to see it in use. Surface area for a cone is pi r squared for your base plus pi times radius times slant height. So over here we see that our radius is equal to 3, and our slant height is going to run down the side of our cone, and it is equal to 6. So we can plug those in, and this is going to be a rather simple solve. So we've got pi times our radius was 3, that's squared. Add to that pi times our radius of 3 times slant height, which was 6.
2 ticks.
And just start simplifying from there. So 3 times 3 is 9.
No.
And if you can't hear him, that's my 2-year-old. Carter, hush. And then we've got 3 times 6, and that is 18 pi. So now we're going to combine those together. 9 plus 18.
18.
9 plus 18 is 27 pi.
Pi.
So in the calculator, do 27 times your pi button.
But.
And this gives us 84, I'm going to give you the big, long, ugly decimal, 84.82300. So we want to take it to the first, this one right here, first tenth. So we want to look at 2. 2 is not bigger than 5, so we're going to keep it at 84.8. So our answer is 84.8. And now for our label, it's going to be centimeters. And surface area is always in 2 dimensions. So that is the answer for our first we do problem. Number 2 is going to be a you do problem. So I'm going to want you to try this one on your own. But I will get you started. Here's our formula. And then you'll need to pull from your image your radius, which is 7. and your slant height, which was 18. And go ahead and try to work this out and pause the video. When you are finished, you can unpause it to see if you got your answer correct. Okay, number 3, the upper portion of an hourglass is approximately an inverted cone with the given dimensions. So over here in the picture, 10 millimeters with a center height of 24. What is the lateral surface area of the upper portion of the hourglass? This is a very tricky question, because they're not asking us to find the entire surface area including this base. So the only part that we're going to be solving is the second half of our equation, which is the pi radius lateral area. So we just need this dimension. But another thing that's tricky is they haven't given us lateral area, which would have been found over here on the outer edge of our cone. So it looks like we're going to have to do a little bit of Pythagorean's theorem in order to find that measurement, which is a little bit irritating. But we're going to do it, aren't we? So they have the base down here, the A of our Pythagorean theorem right triangle, as 10, and then they're telling us that this B is 24. So we need to solve for C. So the way that we're going to do that is we're going to do A squared plus B squared equals C squared. So A squared is 10 plus B squared is 24 equals C squared. So I have squared these and then added them together to get 676. So now to find my hypotenuse, I just need to take the square root of 676. And that gives me a hypotenuse of 26. So this over here is 26, which is actually the measurement that we need. So now we can go ahead and start plugging and simplifying. So we've got pi times our radius of 10 times our lateral slant height of 26. So 26 times 10 is going to give us 260 pi. So the hairy ugly decimal that I get is 816.81408 da 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 da. So for rounding, I'm going to check here. 1 is not 5 or higher, so I'm going to keep it at 0.8. So I'm going to get rid of all this. And then our measurement, for our label, we had millimeters. Well, we were just finding the lateral surface area, which is part of surface area, so it's still just squared. Okay, our last number 4 we do together is another one that's just like before. So going back to the original equation to find surface area, the original surface area is pi r squared, and this is for our base, this piece right here of our circle, and then plus pi radius lateral area, which is for our slant height, which is for our lateral area. So they just want us to find, for this one, lateral surface area. They don't want us to include base again. So for this one, again, we're just going to use this piece. I will say that when you do your practices, the you-dos, you are finding all of surface area, which should make life a lot simpler. So now that we know that, let's go from there. So let's pull some measurements from our cone. So our cone has a radius, you can tell just from looking at the picture, a radius of 9. But this one is going to be pesky also, just like the last one, and our slant height's not going to be directly given to us because they're giving us a B or a center height of 12, but they're not giving us our C. So we're going to again use Pythagorean theorem. A squared plus B squared equals C squared in order to find the length of our C. So if our A is 9 and our B is 12, what is C going to be? So I'm going to take the square root of both sides, and we're going to find that C is equal to 25. Is that right? That doesn't seem right. Yeah, it's not right because it's 15. 15 times 15 equals 225. So over here, our C is equal to 15. So lateral height, slant height is actually 15. So now that we have that, let's work our magic. So we've got pi times radius is 9.
Apple pie.
Apple pie, Carter? Seriously? Times 15 for our slant height. 9 times 15 equals 135 pi. So we're going to go to our calculator and just multiply by our pi button, which is going to give us this decimal, 424.115 da 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 da. But 1 is not 5 or bigger, so we're going to just keep it 424.1. So 424.1, and we are measuring in inches. And again, surface area is just squared, even though it's just part of our surface area, it's still squared. So the final two questions won't be as hard for you to do, your U tries. You're going to find surface area, which is using the full equations, the pi radius squared. Feels like we didn't have much practice with that. Plus your lateral area, which we've gotten plenty of practice finding, which is just pi r slant height. And what's nice is that they have given slant height and radius for these, so it's not going to be too hard. It's just computing. So for both of those, I would like for you to attempt to solve these, and then if you want to check and see if you've got your answer right, just pause the video and I'll flash the answer at the bottom after you unpause it. Get. Okay, so hopefully you tried those and you were close or got the right answers. If not, be sure to ask questions and see where you're messing up. Tomorrow we will get plenty of practice on this, and make sure that you show this to me or turn it in so that you can make sure you get your credit for it. Good luck, guys. Let me know if you have any questions.